Your AI can write code all day, but ask it what actually happened in your database yesterday and it goes quiet. It can't see your systems. In this video, I give Claude Code hands a live connection to a real shop database. Then I hand it a mystery. Yesterday's revenue report says $0, and that's impossible. The shop was busy. You'll watch it query the live data, find a bug the code alone could not prove, and fix it. This is MCP, and it changes what an assistant can actually do. Here's the wall every assistant hits. It lives in your terminal, it can read your files, your code, your Git history, and that's where its world ends. But the things you actually care about live somewhere else. In databases, issue trackers, dashboards, monitoring. So until now, you were the bridge. You run the query, copy the rows, paste them into chat, and hope you grab the right thing. Slow, manual, and mossy. The assistant is smart, but it's working blindfolded on secondhand information. MCP removes the blindfold. The Model Context Protocol is an open standard. Think of it like a universal port for AI tools. On one side, a small server that knows how to talk to your system, your database, your issue tracker, your browser. On the other side, Claude, which sees that server's abilities as tools it can just call. The wiring is one small config file in your repo, .mcp.json. Check it into Git, and your whole team's assistant gets the same hands. There are hundreds of these servers already. Today, ours is a shop database. Let's make it real. This is a little shop's reporting repo. Orders flow in from the web store and from the till at the counter into a live database. One report script prints revenue for a day. July 4th, $373, fine. July 5th, $0, zero. The shop was busy that day, so something is lying. The database is wired up through a read-only MCP server called shopDB with two tools, schema and query. One instruction, find the real cause using the shopDB database tools, fix the report, and make sure this can't silently happen again. Watch the hunt. First, it reads the report code and spots the suspect. The report only counts orders whose status equals paid in capital letters. Then, instead of guessing, it reaches through its new hands. Called shopDB, ran the query. And there's the smoking gun, its words, not mine. The data store status is lowercase paid, but the report queries for capital paid. It even checks whether the change hit one system or everything, and then lays out the whole picture in a little table. July 3rd, uppercase, works. July 4th, uppercase, works. July 5th, lowercase, $0. The shop was fine. The report was broken. Not wrong logic. An exact match too rigid for data that quietly changed shape overnight. Now the fix against live data. It rewrites the report to normalize every status, so paid counts however any system spells it. Then it proves it straight from the database all 3 days, July 3rd, unchanged. July 4th, 373, unchanged. And July 5th comes back, 18 paid orders, $279.50. The real number recovered, and for the make sure part, it goes further than I asked. If this report ever meets a status it doesn't recognize, it now refuses to print a number at all. It errors out and names the offending values, because a loud failure beats a plausible-looking wrong number. In its own words, that directly kills the failure class. Silent under reporting, gone. And databases are just the beginning. The same port connects issue trackers, so you can say, implement the feature described in ticket 4521. Monitoring, so it can check what an error spike actually looks like. Browsers, design tools, payment dashboards. Some servers run locally next to your code. Others are remote services you authenticate to. And because the config lives in the repo, hands are a team decision, not a personal hack. You choose what your assistant can touch, and everyone gets the same reach. Now the honest part, because hands come with risk. A tool that can read your data can leak your data, and a tool that can write can break things. So treat reach as something you grant deliberately. Prefer read-only servers, ours refuses anything that would write. Review what a project's config wants to load before you approve it. And remember that whatever a tool returns is just text from outside. If it contains instructions, your assistant might follow them. That's called prompt injection, and it's the reason you keep dangerous abilities off the table entirely. So that's the full arc of this masterclass. One file that teaches your AI the rules. A team that checks its own work, skills it keeps forever. And now hands that reach into real systems. That's an assistant that has stopped being a chatbot. Everything you watched was a real session, nothing staged. Up next on the channel, we put the other coding agents through the same paces, starting with Google's Gemini. And if you want the foundations, how these models think, token by token, the full free course is on the channel. Subscribe and go give your AI something real to do.